So today I'll be introducing phase shifts. Phase, shifts. So the graph of sine x is represented by a sine bx plus c plus d, where a is still the amplitude and the period is going to be 360 divided by b, but c is a horizontal shift. And d is our vertical shift. So if we are given that c is less than 0, then we are shifting the graph to the right. If c is greater than 0, then we'll be shifting it to the left. Please take note that if c inside the bracket is a negative, then you are shifting the graph to the right. But if c is positive, you are shifting the graph to the left. This differs with the d. If you have your d less than 0, then you are shifting downwards. It's a downward shift. But if your d is greater than 0, then it's an upward shift. So putting this into an equation, suppose we're given that y is equal to sine x plus 30 degrees. So we know that generally the graph of sine x is going to be like this one is going to have 90, 180, 270, and 360. So an amplitude, as on the graph, on the equation, the amplitude is going to be 1 and a minus 1. So the graph of sine starts from the origin. I'm going to sketch the graph of sine at first, and then we're going to sketch the shifted graph. Pardon me, there it's going downward, then to the root. So it's going to be something of this nature. But now we are shifting the graph 30 units to the left. So meaning that in the place of 90, let me use a different color. In the place of 90, we're going to have a 60. We subtract a 30 on every point that we have on the x-axis. So we're going to have a 240, and we're going to have a 330. So the amplitude will remain there at that 1, and then we know that here we're going to have the turning point at the first one, and then we're going to have our root. We have a turning point. We have a turning point here, and we have a root here. Notice that at 0, we are going to shift the graph. Let me just pull that up at minus 30. So at that minus 30, we're going to have a root. So our function of y is equal to sine x plus 30 is going to be like this. So that is our function for y is equal to sine of x plus 30 degrees. And then let's consider a cosine function. For a cosine function, suppose we are given that let's say g of x my g of x is equal to 1 over 2 cos 1 over 2 x minus 30 degrees plus a 1. So the first thing that we're going to do is to draw the general cosine function based on the value of a and on the value of b. So our amplitude is going to be 1 over 2, and our period is going to be 720 degrees, interval of 180 degrees. So sketching the function, the cosine function, we're going to have our 180, 360, 540, and we have our 720 degrees, and our amplitude of a half. So starting from the origin, our cosine function is going to be, let me just sketch it on a black so I can use a different color for the shifted function. So this is going to be just that. So now we are shifting the function 30 units to the right and 1 unit upward. So meaning that on the amplitude we are going to add a 1. So 1 plus a half, that's just 1 and a half. And then a negative half plus a half, that is just going to be what? That is going to be it's going to be a half. So meaning that our range of the function is going to be from our, let me just draw the new x-axis. The new x-axis will be at x is equal to 1, so it's going to be something like that. And then we have our range from a half to a 1.5, and then we're shifting the graph 30 units to the right, so meaning to each term we're going to add a 30. So we're going to have a 210, we add a 30, we're going to have a 390, we add a 30, we're going to have a 570, and then we're going to have a 750. So now we know that at okay, from 0 we're going to add a 30, so we're just going to have a 30. So now our function is going to be something of this nature. At 30 degrees we're going to have our graph at the amplitude, and then at 210 degrees we have the graph at the root. Just don't understand why my pen is acting out. And then at 360 we're going to have a turning point, and I'm so sorry, not at 360, we're going to the 390 we're going to have a turning point, and then at 570 we're going to have a root. At 750 we're going to have our turning point. So meaning our cosine function is going to be something of this nature. This is a shifted cosine function of half cos half x minus 30 degrees plus a 1. Remember, this is not drawn to scale, so we won't be having it on scale, unfortunately. Okay, moving on, we are going to be treating questions based on the sine and cosine functions. So here we're given the functions half sine half x and cos x minus 1 and sine of x. So describe inverse transformation with g of x to h of x. So remember that for a cosine function to be a sine function, we have to shift it some units to the right, which is just going to be a 90 units to the right. And then to make this function to be a cos x, g of x to be cos x, we must shift it 1 unit upward. So we shift number A, we are going to shift, we shift g of x, we shift g of x 1 unit up, and then we shift at 90 degrees to the right. That is going to give us the graph of sine of x. So number B here, we're asked to write down the period of f of x. So the period, you remember, that is going to be 360 divided by b. So we have 360, we're going to say p is equal to 360 divided by a half, which is going to give us a 720 degrees, meaning the period of f of x is equal to 720 degrees. And then we're asked now to write down the amplitude of g of x. You're just going to say that a is equal to, remember the amplitude is the coefficient of the function, which is just a 1. So the amplitude is equal to a 1, and we are done like that. So now they say make neat sketch graph of f of x and g of x on the interval minus 180 less than or equal to x less than or equal to 180, labeling intercepts and turning points. Redraw the grid below. So I'm not going to redraw the grid. I do have the grid, but I'm not going to redraw it. I'm going to draw on top of it. I don't have that precious time. So we are to sketch the graph of f of x is equal to minus sine half x and g of x is equal to cos of x minus a 1. So now we know that the period of sine x, the period of f of x is 720 degrees. That's something we shouldn't make a mistake of. Let me take you to the other page. Now we have our sine, our f of x is equal to minus sine half is just the 1/2, x 1 over 2x, or just like that. And then our g is equal to cos x, g of x, our g of x is equal to cos x minus 1 minus a 1. So I'm going to use different colors for sine x. Remember that sine of x is the the graph of sine is going to start at the origin. Alright, the graph of sine is going to start at the origin, and from the origin it goes to the turning point. Remember that the period of sine is 720, meaning that the interval is going to be 180 degrees. So we are going to have our sine graph starting from the origin, and the amplitude is just a 1. From the origin it goes to the turning point. You remember that? From the origin it goes to the turning point, and also here we're going to have a turning point. Remember, it's going to go down. So we are going to have something like this, something of this nature. That's a turning point. And also okay, this is not supposed to be here, it's just not supposed to be there. It's supposed to be elsewhere where it makes sense to me and to you. It must be a negative 1. So it must be a negative 1. And okay, so the graph of negative sine half x in the interval is going to be that one. And then the graph of cos x minus 1, the graph of cos x minus 1 is just going to be, let me draw it in a different color. So it's cos x minus 1, that's cos x, unfortunately, but that's supposed to be a cos. So we know that the graph of cos x minus 1, we're shifting it 1 unit downward. So it was supposed to be starting at 1, but because we're shifting it a unit downward, now it's going to be starting at a 0. But since it was going to be starting at 1 to negative 1, now it's going to be at 0 to a minus 2. So we know that this is in the interval of 90 degrees, 90 degrees, 90 degrees. So in the first place, our new x-intercept will be flowing on the negative 1. So we know that the graph will start at 0 and goes to the origin, and from the origin it goes to the turning point. And also the same applies as this one. It will go to the origin, goes to the origin, and from the origin it goes to the turning point. So the function is going to be something of this nature. It's going to be of this nature. So meaning that our two functions are going to intercept at x is equal to negative 90 and at x is equal to 0. So I would kindly request you to work on these on this given equations. I'll appreciate if you could work on these given equations.